welcome to another video. I hope you're ready to flex those brain muscles because today we're going to solve some systems of linear equations. And in this video, we're going to do this by graphing. I know there's substitution and elimination as well, and I'll do other videos on those. We're going to focus on graphing. This is my first video on this topic, and I feel like this is a good way to introduce this, to start with graphing, to see how this works visually. So, first of all, what is a system of linear equations? Well, systems in this case just means a collection. So we have a collection of linear equations. In other words, two or more. But in the case of these videos, we're just going to work with two, and they're going to have two variables, x and y, right? So what are we doing when we solve a system of linear equations? Well, what we're doing graphically, if you want to think about it graphically, since in this video we are solving these by graphing, what we're doing is we're graphing this line, and then the solution is the intersection of these two lines, right? If you want to think about it algebraically, we need to find a real number x that we can substitute into both these x's and a real number y that we can substitute into both these y's that makes this equation true and this equation true. And what does it mean by true? Well, I mean that we get something like -5 equals -5, which is a true statement, and something here like 10 equals 10. So these x's need to be the same and these y's need to be the same. And if that x and y makes this true and this true, then that is a solution of our system of linear equations. So our solution we write as a point, right? It's an x and y coordinate. It's written as a point. That's our solution. And sometimes we may have more than one solution or no solution, and we'll see that in further examples. But let's go and get right into this. So the best way to do this, in my opinion, is to write both of these in y equals mx plus b form, in slope-intercept form, like this, right? And the reason because it helps us to be able to identify the slope when graphing these and finding the intersection. It does help us, and we'll kind of see why in a second. But we could graph these in standard form, how they are, just by finding x and y intercepts and drawing a line in between them. But it's beneficial to know the slope, so I'm going to go ahead and rewrite this equation 1. I'll start with equation 1 in slope-intercept form. So I'm basically solving for y, right? So I'm going to add 2x to both sides in this case, plus 2x plus 2x. So I'm left with what? y equals 2x minus 5. Y equals 2x minus 5. And again, you have to have a basic understanding of how to graph linear equations. So click up here if you don't, because that will make this video make a lot more sense if you already know how to graph these. So this is already solved in y equals mx plus b form, right? So now I can move on to equation 2. I'm going to use a different color, keep everything real organized. So equation 2, what do I have here? I can subtract 6x from both sides. Minus 6x, and that leaves me with 2y equals -6x plus 10. All right? And you could have wrote 10 minus 6x. That's the same thing, but I want to make it look like this, where I have mx plus b. So now I divide both sides by 2, and that's going to get my y by itself. 2y divided by 2 is just y. -6x divided by 2 is -3x. 10 divided by 2 is 5, so I have -3x plus 5, and that's what y equals. So now let's go back to equation 1. We'll graph that first. So we know our slope is 2, and our y-intercept is at -5. So I can start at the y-intercept, 1, 2, 3, 4, -5, and I can use my slope. 2 is the same thing as 2 over 1, and if I remember, rise over run, right? So I'm rising 2 and running 1, if you want to think about it that way. Up 2 over 1, up 2 over 1. And again, this is not a perfect graph. I apologize. But it's going to be enough to get the job done, all right? So I'm going to draw a line straight through here. I think that's going to be as good as it gets. Okay, so that's our first line. Y equals 2x minus 5. And I just used the y-intercept and used the slope. And I'm going to do the same thing with this line. Y equals -3x plus 5. So I'm going to start at plus 5 up here. And I'm going to use the slope, which is negative, which means I'm rising, but in the opposite direction. I'm going down 3. So 1, 2, 3, and over 1. 1, 2, 3, over 1. Oh, it looks like this is the intersection. 1, 2, 3, over 1. But we can verify that to make sure. Let's see, I'm going to draw my line through here. This is not perfect. I'm so sorry. Okay. So I drew my line through here. It looks like this is the intersection. Okay, this is at x equals 2 and y equals -1. So I'm at this point 2, -1. So I think this is the solution for my system of linear equations, but how can I check? You remember how I can double check? If I can plug this 2 into both those x's, plug this -1 into both those y's, and see if I get a true equation, a true statement, right? So I can plug 2 into here to -2x, and I get -2 times 2, that's -4. And I plug -1 in for y, that's -5 equals -5. So this one checks out. What about the second one? I plug in 2 for x, I get 12x. I'm sorry, I get 12 plus -2, so that's 10 equals 10. This one checks out as well. Sorry about that. I plug in 2 for x, I get 12, right? Plug in -1 for y, I get -2. 12 minus 2 is 10. So that's a way to check your answer. You don't have to do that, but I like to do that personally just because my graphing skills are not the best. My lines are not always perfect. Sometimes if you get thrown off a little, you can write down the wrong answer and just circle it and move on, and you have the wrong answer. So it's good to check. But this is our solution for this system of 2 linear equations. All right, another example. Equation 1, I'm going to get it into y equals mx plus b form. That's my first step. So what am I going to do? Let's see. I'm going to subtract 2x from both sides. -2x minus 2x. And that actually does it. It's only one step in this case. Y equals, let's see, the 2x is gone. So I just have y on the left-hand side. And I have -2x plus 5 on the right-hand side. So a lot of times in one step you can get y by itself. Not every time, but a lot of times. Okay, so now equation 2. Same thing, I'm trying to get the y by itself, get it into y equals mx plus b form. So I'm going to subtract 4x from both sides. Let's see, so that 4x is gone, and I have 2y on the left-hand side. And on the right-hand side, I have -4x plus 8. So now all I have to do is divide both sides by 2 to get the y by itself, right? Now I'm left with y on the left-hand side equals -4x plus 8, but the whole thing is divided by 2. So -4x divided by 2 is -2x. 8 divided by 2 is 4. All right, so now I have my 2 equations, 1 and 2, and they're both in slope-intercept form. So I'm going to go ahead and graph equation 1, -2x plus 5. So I start at plus 5 up here at my y-intercept, and I go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. All right, and I'm going to go ahead and draw my line through here. That's as good as it's going to get from me. All right, that's equation 1. Let's graph equation 2. Y equals -2x plus 4. Maybe you can already tell what's going to happen, but let's go ahead and graph it. So I go up to plus 4, same slope, down 2 over 1. Just stay here, down 2 over 1, down 2 over 1. You can see what's happening, right? Let's see, let me draw a line through these. All right. So yeah, as you can see, these lines are parallel, right? There is no solution, there's no intersection. I could keep drawing these forever, and they're never going to touch because they have the same slope and they have a different y-intercept. So since they don't intersect, there's no solution to this system of linear equations. So since there's no solution, we can just write no solution, and that's our answer. Okay, and by the way, a lot of teachers use the word inconsistent to describe a system of linear equations that has no solution. So you could say this is an inconsistent system of linear equations with no solution. All right, let's do one last example. I'm going to go ahead and start with equation 1. And I'm going to get it into y equals mx plus b form. So I'm going to subtract 2x from both sides. And what do I have? Y equals -2x plus 4. -2x plus 4. All right, now I'm going to move on to equation 2. -6x minus 3y equals -12. Okay, so I'm going to actually move the 6x over to here. So I'm adding 6x to both sides. Plus 6x plus 6x. I'm left with -3y on the left-hand side. On the right-hand side, I have 6x minus 12. Now I have one more step, and I have to divide by -3, right? I need to get the y by itself. I need to get rid of that -2. So -3, that cancels with the -3, and I have y on the left-hand side, which is exactly what I want. And then over here, I have to be careful with my sign. I have 6x divided by -3. That's negative 2x. And then I have negative 12 divided by negative 3. A negative divided by a negative is positive. 12 divided by 3 is 4, so I have plus 4. All right, so we've gotten both these into slope-intercept form. We can look and see that these are the same equation, which means when we graph them, they're the same line. So how do we find the solution then? Well, remember when we did the last examples, we're looking for the points where these intersect, and that's the solution to our system of linear equations. Well, since they're the same line, they intersect actually at infinitely many points. Every single point on this line is also on this line. And since they intersect at infinitely many points, there are infinitely many solutions to this system of linear equations. And another word that a lot of teachers use for something like this is dependent. So whenever we have the same equation, that means they're the same line, and that means we have infinitely many solutions, and these are dependent. Okay, let's finish up by reviewing some vocabulary and noticing some patterns that we saw through the problems that we worked. So let's start with one solution, the first example we did. The lines, when we got them into y equals mx plus b form, we noticed that we had different slopes. Okay, and this is always true for systems of linear equations. If they have different slopes, that means there will be one solution, okay? Another way of saying one solution is we say independent. And we call this consistent. Here's a new vocabulary word. You've probably seen it in your class, though. They call it consistent because there's at least one solution. So one solution and infinitely many solutions are both considered consistent, okay? What about no solution? That was the second example we saw. Same slope, but different y-intercept, right? And this is the cool thing about getting the two lines into y equals mx plus b form, is if you can look at the slopes, if the slopes are different, you automatically know there's going to be one solution. If the slopes are the same, you know that it's either going to be no solution or infinitely many. And then all you have to do is identify the y-intercepts. And if the y-intercepts are different, then you know there's no solution because the lines are parallel. If the y-intercepts are the same, then the slope is the same, the y-intercept's the same, the line is the same, right? And there are infinitely many solutions, and we call this dependent. If there are infinitely many solutions, we say dependent. If there's just one solution, we say independent. And infinitely many is still consistent. So hopefully this video helped. Please leave comments with questions if you have any. Hit thumbs up if you enjoyed. I did the best I could. This was a tough video to make. This is a tricky subject to teach and talk about. So hopefully it helped a little. Hit subscribe if you enjoyed. Keep flexing those brain muscles, and I'll see you in the next video.